Hey, welcome back to the last part of our chapter 5, which is processors and memory. This lesson we're going to be talking about how to upgrade the memory of your PC and answering that question, how much memory should I be having? Now we'll start off with to upgrade memory means to add more RAM to a computer. Now adding more RAM might solve a problem with slow performance, applications that are refusing to load, or an unstable system. Now, when Windows does not have adequate memory to perform an operation, it gives an insufficient memory error, or it slows down to a painful crawl. Now, when first purchased, many computers have empty slots on the motherboard, allowing you to add DIMMs to increase the amount of RAM. Sometimes a memory module goes bad and then must be replaced. Now, when you add more memory to your computer, you need answers to these questions. How much RAM do I need, and how much is currently installed? How many and what kind of memory modules are currently installed in a motherboard? How many and what kind of modules can I fit on my motherboard? How do I select and purchase the right modules for my upgrade? How do I physically install these modules? Well, all these questions are answered in the following sections. So, how much memory do I need and how much is currently installed? Well, with the demands that today's software places on memory, the answer is probably all you can get. Windows 7 needs at least 2 gig of RAM, but more is obviously going to be better. The limit for a 32-bit operating system is 4 gig of installed RAM. Now, a 64-bit Windows installation can handle considerably more. For example, a 64-bit installation of Windows 7 Home Premium can use up to 16 gig of memory. Now, how many and what kind of modules are currently installed in my system? Well, the next step to upgrading memory is to determine what type of memory modules the motherboard is currently using. If the board already has memory installed, you want to be sure to use the best match the new modules with whatever memory is already installed. Now, to learn what type of memory modules are already installed, you can do the following. One, you want to open up that case and look at the memory slots. How many slots do you have? How many are filled? Remove each module from its slot and look on it for the imprinted type, size, and speed. So, for example, a module might say PC2 4200/512 MB. Now, the PC2 tells you the memory is DDR2, and the 42 is the rating and tells you the speed, and 512 is the size. Now, this is not enough information to know exactly what modules to purchase, but it is a start. So examine the module for the physical size and position of the notches. Compare the notch positions to those on the tables behind me here. Now, you read your motherboard documentation. Now, if the documentation is not clear, and some of it isn't, or you don't have the documentation, look on the motherboard for the imprinted manufacturer model, as you can see behind me in the figure. Now, with this information, you can then search a good memory website like Kingston, Kingston.com, or Crucial, at Crucial.com, which can tell you what type of modules this board will support. Look in the documentation to see if the board supports dual channel, triple channel, or quad channels. And if it does, most likely the memory slots on the board will be color-coded in pairs for dual channels, or groups of 3 slots for triple channels, or 4 slots for quad channels. Now, if the board supports multiple channels and modules are already installed, verify that matching DIMMs are installed on each channel. And if you still have not identified the module types, you can take the motherboard and the old memory modules to a good computer parts store, and they should be able to match it for you. However, this is why you're in training to become an A+ technician, and I'd appreciate it if you would do your homework and not take the computer, your motherboard to a computer store and have them do the work that I'm training you to do. So how many and what kind of modules can fit on your motherboard? Well, now that you know what memory modules are already installed, you're ready to decide how much and what kind of modules you can add to the board. Keep in mind that if all memory slots are full, sometimes you can take out small capacity modules and replace them with larger capacity modules. But you can only use the type, size, and speed of modules that the board can support. And also, if you must discard existing modules, the price of the upgrade increases. So to know how much memory your motherboard can physically hold, read the documentation that comes with the board. Next, let's look at what to consider when deciding how many and what kind of DIMMs or RIMs to add to your system. DIMM modules, you can always install DIMMs as single modules, but you might not get the best performance by doing so. For best performance, install matching DIMMs in all the slots, 2, 3, or 4, on one channel. Now let's look at a few examples. Examples are ordered from a recent motherboard to an older motherboard. So as you study these examples, notice that the older the board, the more complicated the configuration can be, and the harder it is to understand the documentation. Is life of the computer getting simpler or what? Don't think so. Of course it is. Now, motherboard using DDR3 dual channel DIMMs, the Intel desktop board, the DH67GD, as we have shown earlier, has 4 memory slots that use dual channeling. Now these slots are numbered in the user guide as shown here. Now the slots can hold dual channel DDR3 at 1333 MHz or 1066 MHz of 9 ECC 1.35 volts for up to 32 gig of RAM on this board. Now to use 4 DIMMs and dual channeling, you must install matching DIMMs in the 2 blue slots and then matching DIMMs in the 2 black slots. The motherboard user guide said it's possible to use only 3 DIMMs and then dual channeling if you install matching DIMMs in the 2 blue slots, and then install a 3rd DIMM in the black. This 3rd DIMM must be equal in speed and total size of the DIMMs in the blue slots. So for example, you can install 2 4 gig DIMMs in the 2 blue slots and 1 8 gig DIMM in the black slot for a total of 16 gig of RAM. Now if you install only a single DIMM on this board, it must go in the first blue slot, which is the blue slot closest to the processor. Now motherboard using DDR3 triple channel DIMMs, the Intel motherboard shown earlier here has 4 DDR3 memory slots that can be configured for single, dual, or triple channeling. Now the 4 empty slots are shown in the figure here. Now if triple channeling is used, 3 matching DIMMs are used in the 3 blue slots. And if the 4th slot is populated, the board reverts back to single channeling. For dual channeling, install 2 matching DIMMs in the first 2 blue slots that are furthest from the processor, and leave the other 2 slots empty. If only 1 DIMM is installed, it goes in the blue slot in the farther position from the processor. The motherboard documentation says that these types of DIMMs can be used. The DIMM voltage rating no higher than 1.6 volts of 9 ECC DDR3 memory with the serial presence detect SPD. The memory's only gold-plated contacts. Now some modules use tin-plated contacts. So we told you before that you needed to match the contacts with what's on the board with what's on the chip. 1333 MHz, the 1066 MHz, or the 800 MHz. Now it's best to match the system bus speed. Unbuffered, non-registered, single or double-sided DIMMs up to 16 gig of installed RAM. The 3rd item in the list, it needs an explanation. Serial presence detect. Now this is a DIMM technology that declares to the system BIOS at startup the module's size, speed, and voltage, and data path width. Now if the DIMM does not support SPD, then the system might not boot or boot with errors. Today's memory always supports SPD. Motherboard using DDR DIMMs with dual channel. The motherboard that's using DDR DIMMs with dual channeling. We want to take a look at this in our next example of a DIMM installation. The Pentium motherboard allows you to use 3 different speeds of DDR DIMMs in 1 to 4 sockets on the board. The board supports dual channeling and has 2 blue slots for one channel and 2 black for the other channel. For dual channeling to work, matching DIMMs must be installed in the 2 blue sockets. If 2 DIMMs are installed in the 2 black sockets, they must match each other. This board supports the 4 gig of unbuffered 184-pin non-ECC memory running at PC32 or 2700 or even 2100. The documentation says the system bus can run at 800 MHz, 533 or 400. Now depending on the speed of the processor installed, you will choose to either go with the 800, the 533 or the 4. But the speed of the processor determines the speed of the bus, which determines the speed of the memory modules. Now please also remember that if you install slower DIMMs, you're really not doing a very good upgrade on your machine. If you're going to increase the size of memory, please do your best to also increase the speed of the memory. Now, as the figure behind me shows, the possible configurations of these DIMM modules, showing that you can install 1, 2, or 4 DIMMs and which sockets should hold these DIMMs. Now, to take advantage of dual channeling on the board, you have to populate the sockets according to this figure outlined right here, so that the identical DIMM pairs are working together in DIMM A1 and DIMM B1. And another pair can work together in DIMMs A2 and B2, which are the black sockets. Now, the board has 2 installed DDR DIMMs. The label of one of these DIMMs is shown behind me, and the important items on this label are the size, 256 meg, and the speed is 400 megahertz, or it's got a PC rating of 3200. And the CAS latency is a CL3. Now, with this information, the knowledge about what the board can support, we already know to select and buy the memory for the upgrade. Now, for example, if you decide to upgrade the system to 1 gig of RAM, you would buy 2 DDR 400 MHz CL3 DIMMs that support dual channeling. For best results, you need to also match the manufacturer and then buy the Elixir memory. Now, the Pentium motherboard using SDRAM DIMMs, our last DIMM example, uses an older SDRAM DIMM. Now, the Pentium motherboard uses a 168-pin single-sided DIMM module, and the documentation says to use unbuffered 3.3 volt ECC PC100 DIMM. Now, the PC100 means that the modules should be rated to work with a motherboard that runs at 100 megahertz. Now, you can choose to use ECC modules. If you choose not to, the BIOS setup should show the feature to be disabled. 3 DIMM slots are on the motherboard, which the motherboard documentation calls sockets. Each socket holds 1 bank of memory. And as the graphic behind me shows, the possible combinations of DIMMs that can be installed in these sockets. Now, RIM modules, systems that are using RIMs, are no longer made, but you might be able, or you might be called on to support one. Now, because RIMs are obsolete, they're really expensive. So most likely you can purchase a comparable motherboard and processor that uses DIMMs for less money than you can buy the RIMs for one of these older systems. However, if you find yourself needing to replace or upgrade memory using RIMs, if possible, match the new RIMs and with the one already installed on the board. Be sure to follow the guidelines given in the motherboard documentation for the capacity and speed supported. For example, suppose you see installed a RIM like the one we have here behind me. Now, the important information for us is that the 800x16, or 128, the value 128 is the size of the RIM. The value 800 is the speed. And the x16 tells us that the RIM is non-ECC. Now, if it had been ECC compliant, the value would have been 18. That's not enough information to go find a RIM for sale that matches this one. Because if you recall, all RIM sockets must be filled with either RIMs or CRIMs, the continuity RIM. When you upgrade, you replace one or more CRIMs with RIMs. And as you can see with the motherboard documentation, it is essential when selecting memory. Now, if you can find the motherboard manual, look on the motherboard manufacturer's website. So, how do I select and purchase the right memory modules? Well, you're now ready to make that purchase. And as you select your memory, you might find it difficult to find an exact match to DIMMs or RIMs already installed on the board. So if necessary, here's some compromises that you can and cannot make. Mixing unbuffered memory with buffered or registered memory won't work. When matching memory for best results, also match the module's manufacturer. But in a pinch, you can try using memory from two different manufacturers. And if you mix memory speeds, know that all modules will perform at the slowest speed. So let's look at how to use a website or other computer ad to search for the right memory. When purchasing memory from a website such as Crucial or Kingston, look for a search utility that will match memory modules to your motherboard. And these utilities are easy to use and help you confirm that you've made the right decisions about type, size, and speed that you need to buy. And you can also find help if the motherboard documentation is inadequate on other sites. And if you're not exactly sure what memory to buy, let's look at an example on the Crucial site on where we're looking to install memory in the Intel DH6 7GD motherboard that we talked about earlier. And the search results are shown here behind me, and the modules are faster than what the board supports that are listed. But they will work on the board, but they will be back down and run at a slower speed. But it's not necessary to spend the money for speed that you're not going to use. The best buy is the second item that's listed, and these DIMMs are rated at 1333, which is the maximum speed that the board supports. So now we need to talk about how to install them. When we're installing RAM modules, be careful to protect the chips against static electricity. As you learned earlier, to do so, we can use the following precautions. Always use a grounding bracelet when you work. Turn off the power. Unplug the power cord. Press the power button to drain the electricity out of the capacitors. Remove the case cover. Handle the memory modules with care. Don't touch the edge connectors on the memory module or on the memory slot. Don't stack cards or modules because you can loosen a chip. Usually, modules pop into place easily and are secured by spring catches on both ends. Make sure that you look for the notches on one side or in the middle of the module that orient the module into the slot. So now let's look at the details of installing a DIMM or a RAM. For DIMM modules, smaller chips latch into place on each side of the slot to hold the module into that slot, as you can see behind me. Now, to install a DIMM, first pull the supporting arms on the sides of the slot outward. Look on the DIMM edge connector for the notches, which help you orient the DIMM correctly over the slot. And then insert the DIMM straight down into the slot. When the DIMM is fully inserted, the supporting clips should pop back into place. As the figure shows behind me, a DIMM being inserted into a slot on the motherboard. Now, applying pressure on both ends of the DIMM at the same time will cause the two catches to pop into place. Most often, placing memory on the motherboard is all that is necessary for installation, and when the computer powers up, it counts the memory present without any further instruction and senses the features that the module supports, such as ECC or buffering. Now, for some really old computers, you must tell the BIOS the amount of memory present. Read the motherboard documentation to determine what yours requires. And if the new memory is not recognized, power down the system, reseat the module. Most likely it's just not installed solidly in the slot. For installing RIMs, install the RIM beginning with bank 0 followed by bank 1. And to know which one is which, you have to check out your motherboard documentation. Sometimes there will be a 0 or a 1 actually next to the slot. If the C-RIM is already in a slot, remove the C-RIM by pulling the supporting clips on the sides of the socket outward, pulling the chip straight up and out of the board. And when installing the RIM, notches on the edges of the RIM might help you orient it correctly into the socket. Now insert the module straight down into the socket, and when it's fully supported, the supporting clip should pop right back into place. Now, that covers our Chapter 5 on supporting processors and memory and how to install memory. Move on to our online assessment program. Complete any labs or assessments that we have posted for you. Also, there will be a final chapter assessment available. Make sure you complete that before you come on back here for Chapter 6, which is supporting hard drives. Thanks.